In this video, I will show you the basics of developing a desktop multi-platform app in Kotlin. By the end of this video, we will create a working timer app for developers with session saving and displaying said sessions on a graph. To start, go to File, New Project, select Kotlin and click on the link for creating a Kotlin Multiplatform project. Give your project a name and only select desktop. After clicking download, you will get a zip file with your project in it. Open it with IntelliJ, go to main and start your project. If everything works, you should get a desktop application with a button on it. This is where your window is defined. Go to the app function and delete everything inside it. This is where our code will go. Every component that is visible on the window has to have the annotation add composable. There are many layouts you can use in the Kotlin MPA, but the ones we will use are box, column, and row. Layouts give us a way to display items on the screen the way that we want. Just like in React, we can have components inside of components for better readability of the code. Create the container which will house the component composable with our custom parameters. With the modifier, we can give a custom look to our component or give it listeners such as onClick or onHover. The content parameter is everything that will be in the body of the component. In the body, add a box layout with clip, background and padding modifiers, and for its body add the content. Just like the container, we will create the header component which will have the title of our app at the top. Directory picker component will have the container component and the column layout, so everything will be in one column. There we add the text project directory, the selected path, and a visual indicator that the directory was chosen. To the container, add clickable, which will call a function. That function will open a simple dialog box for a directory picker. We can see this is plain Java code that is running in Kotlin. Timer functions component is the same layout as directory picker, but we also have the row layout to show the start, pause, and restart SVG icons. Clicking them calls their respective functions. Based on if the developer has chosen their directory or the state of the timer, we can disable or enable the icons accordingly. For the actual timer display, we will have to add the box with constraints because we need the max height value to make the circle more responsive. With the canvas component, we can draw many shapes. Here we draw two circles on top of each other with different colors, and for the second one we add the offset, which is based on the time passed. We come back to our app component and put everything together. By using columns and row layouts, we can achieve our desired look for the app. We declare our variables with the mutable state of, which act like states in React. Add global variables to the top so we can use them through the whole app. Launch effect is a separate thread that runs alongside the GUI, so we don't have any interruptions while using the app. When the time running state changes, the effect launches, and while it is true, we handle everything we need for the app, such as the current seconds, minutes, and the offset. We can see that the buttons are grayed out because we didn't select a directory. Selecting a directory enables the buttons, and starting the timer, we see the icons, circle, and time changing accordingly. Move everything from app to a new component timer. Use crossfade to smooth the transition from one page to another and create the bottom menu with the layout combinations. Go to build.gradle.kts and add the dependency for our graph. Add experimental material API that allows the use of the API denoted by the given markers in the annotated file. Create the list of months and years and create the exposed drop-down menu for both. When the user selects an item, set the selected month or year to the one they selected and close the drop-down. Create the column chart with our chart data. To save our sessions, we will use JSON. Add a dependency for JSON serializer and create the data classes we are going to save. Because the serializer doesn't recognize local date, we create the local date serializer ourselves. Make the DAO interface, which we will use to create a custom user DAO for CRUD operations on the JSON. When the timer finishes, we call our save session function that stores the session for the specific project on the specific user. For the lines changed, we use a simple regex function at the start of the timer, and at the end we calculate the difference. Coming back to statistics, we can finally create our chart data for each project based on the month and year we selected. We show all sessions for the selected month and differentiate the projects by a unique color. Instead of saving data into a JSON file, we can use SQLite. Add these dependencies in Gradle, and after that, in your common main file, create SQLite com example database. Create 3 files which represent the 3 tables of our database. In them, you write valid SQL scripts for creating tables and also connect them via foreign keys. Instead of writing functions in the Kotlin for storing data, we can create a valid SQL query inside these files and label them with the name. We can remove the JSON code and call the queries with the labels we gave them. The program is now done. Select the path where our Kotlin files are and start the timer. Add or remove lines of code in the files that are in the directory. After the timer finishes, we can go to our statistics tab and select the month in which we edited the files. This has been everything you need to know about Kotlin Desktop Multiplatform app. Bye bye!